Okay, so I hope everybody's doing okay today. It's end of another week. We're halfway through the second 6 weeks, so halfway through the semester now. I don't want you to forget our next big day is going to be on December 13th. So we still have a couple months until it rolls around, but on December 13th, that's when your rough draft is going to be due, and I'll be taking the time to read over those. So if you need anything, if you're having trouble with your topic or getting your data together, please go ahead and come talk to me about that. Because 2 months, it'll actually go pretty quick. Look how fast the first half of the semester is already gone. Uh, as far as in class goes, let's see. We're going to go ahead and continue with our new unit, logic and sets. We're going to get into probability pretty quick. We have a quiz coming up Thursday over the homework that you currently have. And we decided the homework was going to be due when? Monday. Okay, so the homework's going to be due Monday. So that material again is on the quiz, and we're still a couple of weeks out, but I figured I'd go ahead and let you guys make you aware of it. On the 25th, 2 weeks from yesterday, is when your exam is going to take place. Okay, I think that's all I have, unless anybody has any questions. Hey.
Would the exam be like the homework, like
Probably pretty similar. You can expect some Venn diagrams, union, intersection, complements. We're also going to start getting into, and I don't know if we'll be able to make it today, truth tables, things like that. I do need to go ahead and stop about 10 minutes early, so definitely by 1:58, 1:59, I'll go ahead and stop, because you may or may not be aware it was Digital Awareness Week. Okay, so Ms. Campbell has asked me to go ahead and show you a video about being safe online, our smart posters that we've talked about before. So, yeah, all right. So we will take care of that near the end. All right, well, let's go ahead and get to it. In this lesson, we're going to go ahead and start with the definition of a proposition. Okay, that is a statement that is either true or false. Okay, a statement that is either true or false. It does not matter if it's true or false. Now, it's never a question, and it's also not a command. It's just a statement that can either be shown to be true or false. So I've got 5 examples here. Let's go ahead and take a look. First one, proposition or no. Today is Friday. Okay, yes, absolutely. That's a proposition. Even if it wasn't Friday, a false statement, we could still say it's a proposition. What about 3 plus 5 equals 8? That's a proposition. It's just a simple statement. Take the quiz. That is not a proposition. Okay, that is a command. All right, not a proposition. What about 7 is less than 11? That is a proposition. Okay, that can be shown to be true. What about put your hat on? Not a proposition. Okay, very good. Okay. So a proposition is usually represented by the letters P, Q, and R. Those are the ones we use more often than not in IB. The truthfulness or falsity of a proposition is called its truth value. Truth value. Negation. The negation of a proposition can be formed by inserting the word not, okay, or do not, okay, as appropriate. The notation for this negation is going to be, kind of looks like a sideways L, okay? So this is not P. Now, the symbol kind of changes a little bit on some IB exams. You may see it like this, like a little curvy line. You might recognize that as a similarity from geometry, but that can be used in its place. Typically what I like to use in here is that sideways L, okay? But this little symbol right here can also represent the same thing, the negation of an idea. So state the negation of the following proposition. So my proposition is today is Saturday. So how would I negate that sentence? Okay, today is not Saturday. Yeah, okay. So today is not Saturday. Okay. All mammals respire. Okay, so not all mammals respire. All mammals do not respire. Okay. All mammals do not. And I'm going to go ahead and abbreviate because I'm almost out of room. Respire. Go. And our last one, oh, sorry. The glass is full. The glass is not full. There you go. The glass is not full. There we go. Okay, so the truth table for a negation. What we're going to be doing, a proposition can either be true or false, and then we can alter it using these ideas from sets that we were talking about. I'm going to show you that we can include, the union, the intersection, even the negation here. So you'll notice this is the simplest type of truth table we can have. So our proposition can either be true or false, right? So not P, the negation, would just be the opposite of what the proposition originally was. So if it was true, the negation is false. If it was false, the negation is true. Now, one note, this in logic corresponds with P prime, the complement in sets. So this is exactly the same as the complement. We're just now going to go ahead and kind of start showing the similarities with logic. So how would I shade this, the negation of P or the complement of P? Yeah, just everything in the universe except P. There you go. Just like that. Okay. Not bad, right? Easy. Okay. Let's take a look at another one. A conjunction is formed when two propositions are connected by the word, does anybody know? And, yes. Okay, so we've already seen this before, and refers to an intersection. Okay. Now, what's the symbol that we got accustomed to when dealing with an intersection? It was an upside down capital U. Yes, this right here. But there are other symbols that you can go ahead and use. Instead of an upside down capital U, you could have an upside down capital V. It's just a different way of showing that, a different notation, but it has the exact same meaning. So either an upside down capital V, or you can stick with the upside down capital U. Typically in these truth tables, you're going to go ahead and see the V though, the upside down V. Okay. So let's say we have our two statements here. London is the capital of England. Houston is the capital of the United States. Well, a conjunction is formed when two propositions that we have here are just connected by the word and. So London is the capital of England, and, okay, Houston, there you go, is the capital of the, I'm just going to say U.S. Okay. The capital of the U.S. So a conjunction is just an intersection. Everything we've talked about it up to this point is the same. We just have a different vocabulary word. We have a little different notation. Nothing else changes. So here's the truth table. Okay, so you've got four different possibilities, and the size of the truth table depends on how many propositions you have. So we'll talk about how to determine that in just a little bit. But you'll take a note, if you don't look at this last column, all of these are the different possible outcomes you can have when you're dealing with two propositions. They could both be true, first true, second false, first false, second true, or they could both be false. Now, what we're interested in is the intersection based on what we have. Now, you'll notice, take a look, when they're both true, okay, we have a true statement. If only one is true, what's happening? False. If they're both false, then of course our statement's going to be false. And this is the idea when it comes to truth tables. You're trying to show if what you have together is correct or if it's not. Okay, we're ultimately going to be calling those a tautology or a contradiction. But this is the behavior. When you're talking about an intersection, a conjunction, okay, this right here, both statements have to be true in order to get a true statement there. If only one of them is true, the overall idea has to be false. Okay, so this is the same thing as saying P Q. Okay, it's the exact same as P intersecting Q. So how would I show that in a Venn diagram? What part would I shade? Yeah, just the middle. Just the intersection where they overlap. This guy right here. Okay. Any questions? Now, on the formula book that you guys are going to be provided when you go ahead and take the paper exams, typically they do have a truth table set up for you in case you don't remember all of those. But I would really encourage you to, familiarize yourself with the behaviors and the patterns that you're going to see. When you're talking about an intersection, okay, a conjunction, both have to be true for the outcome to be true. If only one is true, can't have it. It's got to be false. Okay, so that right there is just talking about what I was making a connection with sets. So a disjunction is formed when propositions are joined by the word or. So what's this idea? This is the union. Okay, this is the union. All right. Now, we see here in the truth table that a capital V can now be used to tell us we want to take the union. We've known up to this point it's what? Yeah, just a normal capital U. So we could say the union of sets P and Q, but with the V now, it means the exact same thing. Okay. So again, we have the same two propositions. So now I want to state the union of proposition P and proposition Q. And well, what's the only difference in the statement that I just wrote? Yeah, it's just going to be or. Okay. London is the capital of England, or Houston is the capital of the United States. Okay. Do you want me to go ahead and write that out? I mean, the only difference is the word or. You think we'll be okay? Okay, so the statement should say London is the capital of England, or Houston is the capital of the U.S. Okay, so let's go ahead and take a look at this. So this is the first truth table that we're going to go ahead and fill in ourselves. So here's the thing on this. What do you think is going to happen if both of your propositions are true? Okay, it's going to be false?
No, it's going to be true.
It's going to be true. Because remember, what is or telling us to do? The union. We're taking everything, right? So when you're looking at the union, okay, you want to think about it this way. It could be one or the other, or both. Okay. So for a union, only one of them has to be true in order to get a true outcome. You don't have to have both of them to be true in order to get that. So if they're both true, as long as at least one is true, that would be a true statement. If the first proposition is true but the second is false, that would still be true. See, it's already changing from what the union, the intersection was, the conjunction. So false true would be a true, as long as one of them's true with the union.
So it doesn't matter which one comes first?
Does not matter. Does not matter. As long as at least one of them is true, the outcome is true. And what about false false? That would be the only false here. Okay. So if neither of them are true, outcome has to be false. Okay. The truth value of a disjunction is true when at least one of the propositions is true. Okay. Or both. Okay, just like we talked about. So how would I show that in the Venn diagram? The union. Yeah, shade everything containing P and Q. There we go. Just like that. Exactly. All right. Let's see what else we got. Now, the use of or in the disjunctions above is inclusive. That is, either one or the other can occur. For example, Sid shall go home if Rory is running late or it is raining. This sentence means that if either Rory is running late or it's raining, Sid is still going to go home. The or is inclusive because Sid will still go home if both events occur. That is, one event need not occur at the exclusion of the other. Now, here's the big difference. That was what we were talking about. That's referred to as inclusive. This one is exclusive. Okay. The exclusive or means either one or the other, but not both. So only one of these can be true for an exclusive. So it says, for example, you will go to Richmond by plane or by car. In this instance, the or is exclusive because you cannot be on both the plane and in the car at the same time, unless you're Batman. Because Batman can do anything. But anyways, does that kind of make sense? Okay, so this is the difference in the notation, what we're going to be looking at here. So this one here, if you see the V, now that still means union, but this is the inclusive. Okay, this can be one or the other or both. Okay. One or, I'm trying to write this small in that room. One or the other or both. That is perfectly fine. Okay. Now this is the symbol we're going to use for exclusive. It's going to be the same V. It still tells you union, but you've got that bar below it. This is exclusive. Okay. Now this is going to be one or the other, but not both. Yes. So one or the other, but not both. Not both. Okay. And that's the only difference. So take a look. If I go back over here, okay, to the inclusive, remember we were able to get a true as long as just one of them was true, right? Okay, no bar, this is inclusive. Okay. In fact, the only time it was false was when both of my propositions were what? They're both false to begin with. Now let's take a look at the exclusive. Okay, so this one is exclusive. Okay. So in fact, why don't you take about 30 seconds if you haven't already done so. Try to fill in that last column, your outcome. Okay. Now remember, for exclusive, it can be one or the other, but not both. And then go ahead and see by extension, go ahead and shade what you think the Venn diagram would look like to represent this situation. So I can have one or the other, but not both. Is everybody ready as far as the table? Okay. What should I put if both my propositions are true? False. Okay. Remember, if it's exclusive, if it's got that bar, they both cannot be true at the same time. If it doesn't have the bar, that would be true statement. Okay. That'd be perfectly fine. What about if the first is true and the second is false? True. Okay, one or the other, but not both. That's exclusive. False, true? True. What about if they're both false? Ooh, I heard false, I heard true. That would be false. There we go. In order to be true, you have to have just one true for the exclusive. Again, but not both. So this would be false, true, true, false. How many people got that right? Okay. Did we get close for those people not raising your hands? Or is there anything I can do to help? Okay. Does anybody want to tell me where they shaded? Okay, Samir, what'd you get?
Maybe just the crescents of the set pink.
That's exactly right. So I'm going to shade the crescent for P, and I'm going to shade the crescent for Q. That is exactly right. Again, because think about the definition, one or the other, but not both, and the intersection would represent both. How many people shaded that correctly? Okay, good. So a few more hands going up on that, because we probably had a little more, practice with the Venn diagram so far. Okay. How we doing? So we've got the negation. Yes, ma'am.
So if it's one or the other, but not both, the shade both in the same places, like where they overlap, wouldn't it be like? I mean, I know it's not, but wouldn't it be like the part that's not shaded?
Mm-hmm.
You know what I mean?
Yes, it would not be. What you're talking about, the part of the middle? Yeah, the overlap, what they share, cannot happen. Because in this case, think about the example they gave you. They're talking about this guy going to, what is it? Where's the one where it says both at the same time? Yeah, you're going to Richmond by plane or by car, but you can't take both at the same time. It's like, I'm going to go to a movie at 11:30. I'm going to go see Venom, or what else is out now? What's that? Oh, has Halloween started yet?
No, next Thursday.
Next Thursday? Well, for the fun of it, let's just say Halloween. Okay. What's that? The Rock?
Skyscraper or something?
Oh. See, I haven't seen that movie yet, but I'm looking at the trailer, and I'm kind of thinking Die Hard. I mean, Die Hard was a great movie, and I do like The Rock.
I haven't seen Die Hard yet.
You want to watch what? I want to see Night School.
I've seen it.
I do like that. Looks good. Looks good. Okay. All right. So let's go ahead and take a look at these examples right here. And just to recap real fast, we've talked about negation. Okay. So in order to show negation through notation, remember we have that sideways L, or we could use that little curving line. I think we call that tilde is the actual name. I may be mistaken about that. But that's the negation. Then we talked about what's the new vocabulary word for an intersection? Starts with a C. That's a conjunction. Okay. That's a conjunction. And then we talked about a new vocabulary word for a union. Oh, disjunction. Disjunction. So if it's a union, we also have this notation now where it's a capital V. If it's an intersection, we now have this upside down capital V. And then when it comes to union, it's further broken into two other parts. Inclusive, and I forget, does it have the bar or no? Okay, so inclusive does not have the bar. Exclusive does have the bar. That's how you tell the difference. Okay. All right, well, let's take a look at these examples right here. Number one, given the following proposition, so we have M and N, determine if their inclusive disjunction is true or false. Okay, and then it says give a reason. All right. So inclusive, remember, that's another word that's referring to the union, right? So I'm going to go ahead and join these by or. Okay, would everybody agree? Okay. So let me go ahead and write out the sentence. 23 is a prime number. Now I'm going to go ahead and put that. Back in my day, we didn't have hashtags yet, so that was what we used for numbers. Hashtag math. Anyways. 23 is a prime number, or the graph of y equals x squared is a parabola. The graph of y equals x squared is a parabola. Okay. Now you'll notice I'm not going to put a period at the end of that because it's going to depend on what we say. Can both of these be true at the same time? Do I have to choose one and exclude the other? Okay. Well, let's see. We know, is 23 a prime number? It is, right? Okay, any number that's only divisible by 1 in itself. But at the same time, the fact that 23 is a prime number, does that in any way influence that the graph of y equals x squared is a parabola? No, so they can both be true, right? Okay, so this one is inclusive. So I can say at the end of this, or both, because it is inclusive. Both of these can be true at the same time, right? Okay. Now let's try the next one. 42 is a multiple of 4. 42 is a multiple of 3. Okay, so I'm going to say 42 is a multiple. Yes. Oh, we're saying true, though. Yeah, because both statements are true at the same time. Oh, yeah. Yes. Yes. So this is definitely a true statement. I'm sorry, I just didn't write it down. True. Okay. All right. And then 42 is a multiple of 4, or 42 is a multiple, okay, of 3. And again, I'm not going to finish that up. So 42 is a multiple of 4, or 42 is a multiple of 3. So what do you think? Would this end up being a true or a false statement? And what would I put at the end of it?
It'd be false because 42 is a multiple of 4.
Okay, so what are we thinking here? Inclusive or exclusive? Exclusive. Okay, so 42 is a multiple of 4, or 42 is a multiple of 3, or not both. This is an exclusive. Okay, because they both can't be true at the same time, right? Because as Eli just pointed out, 42 is not a multiple of 4. So what would I say about this one?
True.
This one's true?
It tells that it's exclusive.
Okay. All right.
Wait,
But think about the exclusive. Think about the pattern here.
I think it's
that is false because we can't. Because
It's true because one of them's true and the other is exclusive.
There you go. It's going to be a true statement. It's going to be a true statement. Okay, now think about the behavior that we were just looking at on the chart over here. Okay. The only way that exclusive is going to be false is if what?
it's both of them.
If both are true or if both are false. As long as one of them is true but not the other, then it's going to be exclusive and that's a true statement. So here, that's exactly what we have. The first one is false, the second one is true, so this is a true statement. Okay? Or I could probably say but not both is probably a better way to say that. But, okay. There we go. Okay. Questions. How are we doing on truth tables? Logic. Okay. Every time I teach this lesson, I just want to start flashing. You guys know what I'm doing, right? Vulcans? Okay. The most logical race in the galaxy. Okay, why do I kind of feel like you're just humoring me? Like, yeah, I know what you're talking about. I don't know. Okay, I just want to make sure. Okay. Okay. Has it been a long week? Oh, okay. All right.
That's what I was going to ask. Isn't it?
Well, I'll tell you what. How about we at least go ahead and set the groundwork for this next problem? Because remember, I still need to go ahead and show you that video. We're definitely not going to be able to finish this up if we're going to watch the video. So we'll just go ahead and create the sets, okay? And then we'll go ahead and pick this up on Monday when I see you guys after we talk about the homework. Okay, so it says let U, okay, our universe, be the set of all counting numbers from 0 to 50. So 0, 1, 2, 3, 4, all the way to 50. Okay. Now it says for proposition P, X is an odd number between 0 and 20. Okay, so P, go ahead and give me the elements of that set. Okay, so odd number, so 1, 3, 5. There we go. And then Q, X is a factor of 45. All right, so we definitely have 1 and 45. 5 will go in there, 3 will go in there. Okay, we got 5. There we go. And then 9, 15, that's a 15. And 45 itself. Okay. All right. And then what we're going to do when we come in on Monday is we're going to complete parts A through D. We're going to first write a statement and then move on. But let's see here. What is this notation telling me right here for P and Q? The intersection. Okay, so we want the conjunction of the two. Remember, that's the word and. Okay, what about over here? That's the disjunction. So it's a or, okay, so it's a union. Inclusive or exclusive? Inclusive. Inclusive does not have that bar. Exclusive does. Okay, and then what's that little sideways L? That's the what?
The P.
Hey, okay, the complement. Yes, that's the negation of that proposition. Yes. Okay, very good, very good. All right, so let's go ahead and stop there. I think we did good today.